Hello everyone. In this session, I'm going to give a brief introduction of Score, the smart contract for Icon, what it is, and how to write a score. After my presentation, we are going to do a hands-on session where you can practice actual writing of Score code and deploy it to either the local environment or testnet. What is a smart contract? Here's the definition from Wikipedia. If I rephrase the meaning from the viewpoint of a programmer, it would be a smart contract is a collection of code and data that resides at a specific address on the blockchain. In Icon, we call a smart contract a score. Score stands for Smart Contract on Reliable Environment. So from now on, I will use the term score on behalf of smart contract. A unique aspect of Icon Score is that its programming language is Python, which is a general purpose programming language. And this language is easy to learn and already popular nowadays. So if you're already familiar with Python, you can write Score code right away without running a new language. And Score provides state-DB abstractions like var-DB, dict-DB, array-DB. I'm going to explain the details later. So the most important thing you should remember is that sandbox policy. I'm going to explain this in the next slide as well. You can think of Score code as a state transition machine, and the state transition is triggered by sending transactions. Let's think about transferring coins. If you want to send some ICEX coins to your friend, you must make a transaction message and send it to the Icon network. Then your balance will be decreased by the amount of requested ICX. And your friend's balance will be increased by the same amount. This is a state transition. Balance state changed. Beside this simple coin balance change, any problems that can be modeled by a state transition machine can be implemented in Score code. Sandbox policy is a very important aspect that every Score programmer should have to know. A transaction sent from a user will be executed on every node that exists on the Icon network, and the nodes will form consensus on the transaction result. So, deterministic behavior is very important when you write Score code because every node should agree on the execution result. Therefore, you cannot use a random operation like using random function, cannot make network call that may get different result depending on the connection, and also cannot make system call that result may also differ between nodes. Also, you cannot do long-running operations in Score that may prevent forming consensus between nodes. These sandbox policies should be obeyed by every Score programmer. Once you deploy a Score on the Icon network successfully, the Score will get a new address that starts with CX. After that, you can send a transaction to the address of Score. When you write Score code, tools and test environment are essential parts of the whole development process. So, we provide Score development suite called T-Bears. Using T-Bears, you can generate a Score project template. And with this template, you can start coding right away. T-Bears also provide an emulated Score execution environment where you can test your Score locally. After testing your code on the local environment sufficiently, and when you're ready to deploy your Score to the real Icon network, you can deploy the Score onto the Icon network through T-Bears CLI command. Also, T-Bears provides additional CLI commands to interact with Icon network that is basically implementing JSON RPC version 3 API. For more information, please see the T-Bears GitHub repository. Here is the big picture overview of the components of T-Bears. There is an Icon RPC server that accepts JSON RPC requests from various clients like wallets, exchanges, and in this case, Tvers CLI client. And there is an Icon service module that is responsible for actual score code execution and management of scores. On another side, Tvers block manager does an emulation of block generation. All three of these components communicate with each other through message queue interface. You should know that the only difference with the rear icon node is the Tvers block manager module. That module will be replaced with the loop chain consensus engine in the rear icon network. There are two ways to use Tvers for your local development environment. One is to install Tvers on your local file system directly, and the other is to use the pre-built Docker image. Here is the basic procedure to install Tvers on the file system. It is assumed that you're using Linux-compatible environment like Ubuntu and macOS and Bash. Set up virtual LAN first and enter the virtual environment by executing the second line code. Then run pip install tvers. That's it. Pip install checks the package dependencies automatically. So all the required packages will be installed along with Tvers. After installing Tvers package successfully, this Tvers start command will start the Tvers server process like RPC server and icon service. We also need to install a message queue server package called RabbitMQ to work with Tvers. It is a little bit annoying to install all of this on your local file system and start those as demo servers. That's why we provide the Tvers Docker image. If you issue the docker run command, the pre-built Tvers Docker image will be downloaded first, and then it will start a Tvers service in the container that is listening on the port 9000 for incoming request. Here are some Tvers CLI commands. Init command is for initializing a score project and generating template files. Key store command is for creating a key store file that can be used for signing a transaction. Deploy command is for making and sending a deploy transaction for deploying your score onto the Icon network. For more information, you can refer to the Tvers help messages. Now, I'm going to explain the basic score syntax briefly. The main entry class of score must inherit icon score base class as its parent class, so that icon service engine can recognize its existence and load the score code properly. Init is the normal Python class initializer, also known as constructor. You can put all the instance variable installation in this function. On install is called when the score is deployed onto the network for the first time and will not be called again afterward. So this is the right place to initialize the state DB variables. There are some decorators, external, payable, event log to provide special meanings when they are marked to functions. Only the functions that are decorated with external can be called from outside the score. These functions are registered on the exportable API list, and you can get this list by issuing score API command using Tvers. Functions with payable decorator are permitted to receive incoming ICX coins. If ICX coins are passed to a non-payable function, that transaction will fail. Functions with event log decorator with include logs in its TX result as event logs. So you can leave any log messages that you need to find later from the TX result. Fallback is a special function and reserved keyword in score. A fallback function is executed whenever the score receives plain ICX coins without data. But remember, if you want to receive ICX coins delivered to the score, the fallback function should be decorated with payable. VADB, DICDB, and ArrayDB are utility classes wrapping the stateDB. VADB can be used to store a simple key value state, and DICDB behaves more like Python dic. ArrayDB support one-dimensional array only. DICDB does not maintain order, while ArrayDB, which support length and iterator, maintains order. When you want to invoke other scores external functions within a score code, you should use interface score. I'm going to explain this by example in the next slides. For more information, you can refer to the depth guide document page. I'm going to show you a more concrete example of how to write score code. First, you need to initialize a project structure. You can do this by using tbear's init command. If you issue the command like project initialization, a project folder named sample token will be created and init.py, package.json, sample token.py are also generated in the folder. A sample token has the main class declaration with the name sample token. You need to fill the actual implementation of sample token class afterward. You can refer to the complete implementation of sample token at the GitHub repository. Let's look into the actual implementation of token score. From icon service import is the default import declaration of score. Due to the sandbox policy, package import is prohibited except icon service and the files in your deployed score folder tree. Sample token class must inherit icon score base class. Several instance variables that are mapped to stateDB are initialized in init function. OnInstall will be called when this score is deployed for the first time and loaded into memory for execution. You can pass parameters like initial supply and decimals to set the initial state of score. In this example, 100% of initial tokens go to the contract owner. There are some read-only external functions: name, symbol, decimals, and total supply. If a function is decorated with read-only parameters, the function will have read-only access to the stateDB. For example, valence of function returns the token valence of specific owner by looking up to the DICDB. Token transfers can be done by sending a request transaction to the transfer function. First, it should check whether the message sender has enough token balance to spend. Otherwise, revert the transaction. Next are simple balance changes. The sender's balance is decreased and the recipient's balance is increased. Next statement is for conforming to IRC2 specification. That is, if 2 is a contract, this transaction function must invoke token fallback in that recipient contract. To invoke other scores function, you need to define a dummy interface class by inheriting interface score. If the other score has a function that has the same signature as defined here with interface decorator, then that function can be invoked via interface score class object. If there is no matched function in the to address, it will raise an exception and this transaction will fail. You can leave some useful event logs in the TX result by calling a function decorated with event log. The event log functions are just dummy functions that only have declaration without implementation body. If you call these transfer event log functions like this, the values of from, to, value, data will be left in the TX result data. If the indexed parameter is set in the decorator, the designated number of parameters in the order of declaration will be indexed and included in the Bloom filter. After writing your score code, you need to deploy it onto the local TBears server to test your score. Here is how to deploy the score using TBears deploy CLI command. First, you need to write some basic information for the deploy procedure, like the URI, where you want to deploy your score to. In this case, local TBears server and network ID, step limit, and so on. You should know that for the first deploy, namely score installation, the destination address should be the special score address, CX0. With this deploy the JSON file and your key store file, you can deploy your score like this command line. After successful installation, a new address will be assigned to the deployed score, and this address can be found in TX result data. Transaction result can be queried by this TX hash. To interact with scores, like invoking an external function in a score, you need to use the JSON RPC API version 3. This is the link for the spec document. There are two major JSON RPC methods to interact with scores. One is to ICX call, and the other is ICX send transaction. ICX call can be used to call a read-only external function of score. This does not make any state transition, and no fee is charged. ICX send transaction causes state transition, and fee will be charged. There are 4 types of transactions: transferring ICX coins, installing a new score, invoke an external function of score, and transferring a message. How can we interact with the score through the JSON RPC API? JSON RPC API is using the HTTP transport layer, so we can just use cur to post HTTP data to the JSON RPC server. This is the ICX call example to get the token balance using cur. But this approach is somewhat cumbersome, so we provide 2 officers SDK written in Java and Python. You can use these SDK to interact with icon nodes and scores. For more information, visit these 2 links. Another way to interact with scores is using TBears. TBears provides various CLI commands. This example shows how we can do ICX call using TBears command. You need to write a JSON file that contains your request data according to the JSON RPC API spec and pass the JSON data file to TBears call command. Transaction fee will be charged whenever you send a transaction on the ICON network and is calculated by use staff multiplied by step price. Step is the unit of measurement for transaction fee, and 100 million step is equivalent to 1 ICX. Use staff indicates how many steps were used for the transaction execution and will be increased whenever some operations are performed like DB access and function calls, and it also depends on the overall transaction data size like input parent size. Step limit is the maximum step allowance that can be used by the transaction, and this should be set by the transaction sender. While a transaction executes, if use step is more than step limit, then the transaction fails and the fee is deducted. Also, when you request a transaction, if your ICX balance is less than the transaction fee that the sender willing to pay, the transaction will fail immediately without actual execution. For more information, you can refer to our yellow paper, Icon Transaction Fee and Score Operation Policy.